So, if you haven't memorized your little, every little color they are, gold boxes, green boxes, whatever color they are, you need to get them memorized. Because we are going to do some trigonometric proofs. And we'll start, you had some homework the last couple nights, which was simplifying some expressions. So we'll start with that. Yes, people, it's time to get started. Precal stops for no one, except apparently Jesus, I learned at retreat, so. Here we go. Here we go. I am going to do a couple from last night's homework to get us warmed up. So if you did last night's homework and you looked at number 47, we'll start with that one. And we're going to simplify this. I'm going to go ahead and write down a couple more while I'm at it.
I'm liking that. That's what
Okay, so here we go. We're going to simplify these. Like I said, in a little bit, we are going to, oh, John, you just brought this in? Okay, good.
Yeah, that was coming in.
Super. All the ducklings will be in the flock then. Okay, now we're going to be doing some proofs here. That's today's lesson is proofs. In order to do them, you're going to need these simplification skills. So here we go. When I look at this numerator, I see the difference of squares. This is going to happen a lot where you have to factor the difference of squares. So when I say the difference of squares, you should be thinking back to first year algebra when you factor things like this. This is called the difference of squares. How does this factor? A plus B, A minus B, right? Now, these are squares. How is that numerator going to factor? It's going to factor exactly the same strategy as here. So what's that numerator going to be? 1 minus sine x, 1 plus sine x. Everybody see the connection between these? Now, that's over 1 plus sine, so guess what's going to happen? These are going to cancel, and that mess just simplifies to 1 minus sine. All right, look at this one. This is exactly the same thing. Do you see it? This happens a lot. The purpose of these exercises is to get you, kind of in tune to the fact this is something to look for. How does that numerator factor?
Tangent.
Tan plus 1, tan minus 1. Does the order matter?
No.
No. Over 1 plus tan. Now, addition is commutative, so these are still going to cancel, right? And I'm left with tan minus 1. Now, let me just say right now, the study trigonometry is full of Greek letters. This is an alpha, a lowercase alpha. If you do not like to use the Greek letters, put an X in there. It doesn't matter. Put an N in there, put an A in there. It doesn't matter. The variable you use doesn't matter. So don't get all hung up on the letter. Change it if you don't like it. Okay? Now, here is where things get a little bit tricky. This is where you absolutely have to know your identities. Your identities, those of you that looked at them, there were, a total, I think, of 4 boxes. And they were kind of grouped together. Do you remember what I'm talking about? So there was a little group called the Pythagorean Identities. And you'll recognize the Pythagorean Identities because they're the only ones that have squares in them. And does it make sense to you that the Pythagorean Identities would have squares in them? Yes, because what's the Pythagorean Theorem? A squared plus B squared equals C squared. Well, your fundamental Pythagorean identity in trigonometry is sine squared plus cosine squared equals 1. This one absolutely has to be so ingrained in your head because you're going to use it over and over and over again. You absolutely have got to know sine squared plus cosine squared is 1. But here's the interesting part, or the necessary part. You have to know that identity so well that you recognize it in different forms. Here's what I mean. This identity could also be written as sine squared equals 1 minus cosine squared. Do you see how these are the same sentence? Just rearranged a little bit? You have to recognize that every time you see a sine squared, it is exactly the same and can be replaced with 1 minus cosine squared. So when I look at this problem and my directions are to simplify, I'm thinking along these lines, but that's a sine and that's a cosine. So there's no way I'm going to be able to cancel anything, right? So what do you think I'm going to do with this sine squared?
Substitute.
I'm going to substitute. And what am I going to substitute for it?
1 minus cosine.
1 minus cosine squared. Every time you see a sine squared, you are allowed to replace it with a 1 minus cosine squared. Now, I'm not saying you're going to do that every time, but you're allowed to do it. Anytime you see a sine squared, you can replace it with 1 minus cosine squared because of the main Pythagorean identity. Now, what am I going to do with that 1 minus cosine squared? I'm going to factor it. And how is it going to factor?
1 minus
1
cosine.
plus cosine, 1 minus cosine. Kids, this is the difference of squares, just like this was and this was. And as soon as you do that, you can cancel, right? So what does that reduce to? That reduces to 1 minus cosine. This is exactly the same problem, except it's got tangents and secants in it. So those of you that learned your identities like you were asked to, know that there's another Pythagorean identity. There's actually 3 of them. This is the main one. This is the big one, the one that you would use more than any other identity. This is the biggie. But there's another Pythagorean identity that says, anybody know what it says? It's the tangent secant one. What does it say?
1 plus 2 squared.
Yep. Somebody knows them. 1 plus tangent squared equals secant squared. Now let's see. I want to replace that tangent squared. Look at that identity. What does tangent squared equal? What can I replace tangent squared with? Rearrange that identity.
Tangent squared.
Secant squared minus 1. Don't I just subtract 1 from both sides to get tangent squared? So I can take out the tangent squared and replace it with secant squared minus 1. Now, why is that a smart move on my part? Because now what can I do with the numerator?
Factor it.
I can factor it. So that's secant plus 1, secant minus 1, canceling. This thing reduces to just secant minus 1. Now, notice that when I say it out loud, I always just say secant minus 1, but I never forget to put in my variable. You must have a variable. Never write just SIN or SEC. Always have an X or an A or an alpha or a theta. Always have something attached to it. Okay, now that was in last night's homework. Simplification skills. Tonight, you are going to do something much more fun. Tonight, you're going to actually do some proofs. Now, these are not proofs like you did in geometry where you have statements and reasons. These are called Trig Verifications. Here's how they work. Let me put one up here. I'm taking these straight out of your book, so if you want to follow along here, this is number 12 on page 460. sure I copied it right, so that would be disastrous if I didn't. Okay, now here's how this works. You are going to change one side into the other side. At this moment, we don't know if this is an equation. You're proving that it is indeed an equation. And in order to do that, you're going to take one side and simplify it like we just did, and hopefully end up with the other side. Now, I've done a lot of these in my life, so I have some hints I've developed. There are no rules, except, I mean, obviously you can't cheat, you can't use illegal things, but there are no absolute definitive rules. All I can provide you with are some hints. And my first hint is always work. Remember, you're going to reduce one side into the other side. So you're only working on one side. Always work on the side that's harder, that looks harder, that's bigger, that's more complex. So in this case, I'm going to work on this side, and I'm going to try to do stuff to it, and ultimately make it come out looking like this. My next hint for you is change everything into sines and cosines. Now, what do I mean by that? Well, I've got a cotangent sitting right here. What's cotangent? Now, again, this is one of the identities you were supposed to memorize. I forget what that little grouping is called. What? 1/2. Okay, 1 over tangent is exactly, cotangent is 1 over tangent, there's no question about it. But I want to change it into sines and cosines. What's cotangent in terms of sines and cosines? Cosine over sine. You got to know that. It's cosine over sine. If you think back, that makes sense because one of our definitions for cotangent is x over y. X is associated with cosine, y is associated with sine, cosine over sine. So I'm gonna replace this guy with cosine over sine. And then I'm going to replace the tangent here. What am I going to replace the tangent with? Sine over cosine. So far, I've decided to work on this side because it's bigger, it looks more complex, it's harder, and I've changed into sines and cosines. Now I'm going to do my basic arithmetic, and what do I mean by that? Well, in this case, do you see a distributive situation? I'm going to distribute. Sometimes we factor and cancel, like we did in our earlier examples. Sometimes we have to get common denominators. All kinds of basic arithmetic is possible. Well, I'm just going to distribute. Well, what happens when I take this times this? What do I get here? All I get is cosine. Would everybody agree with that? That when I multiply these two things together, the sines cancel and leave cosine? Now, I got to take this times this too. Well, now wait a minute. What's happening here? Those are canceling, right? So what happens when I take sine times sine? I get sine squared. Lo and behold, kids, isn't that what we wanted to end up with? Okay, this is a big moment in your lives. You just proved your first identity. There it is. That's the objective of today. That's what we're doing today. Let's try another one. Let's look at number 14.
That was a sad but great day. We changed it.
Terry, contain your enthusiasm.
Oh, I'm sorry.
Okay. Now your job is to change one side into the other side. So take a look at the problem. What thought do you have? What occurs to you to do? Foil it out? Multiply this out? So this would be cosine minus sine times cosine minus sine. Right? Remember, technically, there's a question mark here. We don't know if this is true. Our job is to prove it. All right, so what do we get when we FOIL this? Well, we get cosine squared minus cosine sine minus sine cosine plus sine squared. I am simply FOILing first times first, outsides, insides, and last. Everybody okay with that? Now, these two are like terms. Would you agree with that? So those two can be put together, and that just becomes minus 2 cosine sine. I don't know about you, but my heart is leaping out of my chest. What do we see here? 1. Cosine squared plus sine squared is always 1. Mr. Stark? What are you doing, Angel?
Nothing.
Okay. Let's do something that's
Okay.
math related. Thank you, birthday boy. Cosine squared plus sine squared is always, always 1. So these two things become a 1. Now, look what we have. Look what we wanted. Are we there? We are indeed. You did it. You did it. I would like you now to look at I am on page 460, so if you have your book, get it out. And I want to do whatever problems you want me to do from the evens. So look on page 460. Look on page 460 and pick an even problem. 460. Pick an even problem. This really isn't hard. Just pick one that looks like, oh my goodness, that might be challenging for me. 18. Let's look at 18.
Oh, Maggie.
Okay, no question about it. This is a much tougher problem.
So aggressive.
Now, I know what the temptation will be.
Cross.
Some kids will say, let's cross multiply. But remember, we do not know if this is an equation or not. We are proving that it's an equation. So you are not allowed to do things that you do with equations. You aren't allowed to cross multiply. This isn't an equation. We don't know if it's an equation. So you got to pick a side and work only on that side and leave the other side alone. So looking at this, which side do you think you might want to work on? Here?
That side is harder.
I would work on this side personally because I know how to start. I've got a secant squared minus 1. I can do something with that. Okay? Now there are two things you can do with this. And I don't know which way is going to be easier. So you just got to pick one. Can anybody think of something to do with this secant squared minus 1 thing? We could factor it. Now let's talk about that. That does factor. Does everybody see that?
Yeah.
Yes.
Will anything cancel, though, after I factor it?
No.
So while I can factor it, and you would not lose points for factoring it, because that's a legit operation, you can do that, I think you'd be stuck at that point. Okay, I got it factored, now what? See what I mean? So what's something else we could do?
Try to change it to sine.
Change it to sines and cosines? So, tell me about secant squared. What's secant squared? Okay, now be careful. We're going two different ways here. Secant squared is 1 over cosine squared. So this is one option, Katie. This is one option. Somebody said change into sines and cosines. This is what it would look like if I did that. You're going an entirely different route. You're saying, wait a minute, pitter patter, secant squared minus 1 is something. I have an identity that says 1 plus tangent squared is secant squared. So anytime I see a secant squared, this pops into my head. Now I happen to have a secant squared minus 1. What is secant squared minus 1? Tangent squared. So my two choices are when I start this problem, I can either go this way, changing into sines and cosines, or I can go your way and rewrite the numerator as tangent squared. So this will be somebody's first step, and Katie, this might be your first step. Okay? Now, we'll go both ways, but let's finish one at a time. So let's suppose you chose this route. You said, you know, my teacher told me to change into sines and cosines, so I'm going to change into sines and cosines. Now, I'm really glad that we got to this point because this needs to be simplified. And you need to be good enough algebra students to simplify this without issue. It's not hard at all. To simplify that, my suggestion is, and you can do whatever you want as long as you end up with the right answer, but my suggestion is you simply multiply each term by cosine squared. Now, why do I do that?
Can you get rid of the cosine?
This will cancel. Do you see that? So now I have 1 minus cosine squared over sine cosine squared. So a minute ago I had this like fraction inside of another fraction. I don't have that anymore. Do not try to cancel these cosine squares. See that minus sign right there? That ruins everything. You cannot cancel parts of the problem. You can either factor and cancel or you don't cancel. There's no canceling at this point. Now when I wrote this or said that out loud, did anyone's heart jump for joy? 1 minus cosine squared. What's 1 minus cosine squared? Sine squared. So now I'm going to take that numerator and I've got sine squared over sine cosine squared. This numerator is sine squared because of the fundamental Pythagorean identity. Now take a look here. Are there any pluses or minuses now in this problem? No adds and subtracts, so I can cancel. So I'm going to cancel here, and I'll be left with sine over cosine squared.
Cosine squared minus.
Remember, this is what you want to end up with. Are we getting close? We are there, because what's cosine squared? 1 minus sine squared. So we have sine over 1 minus sine squared, and you did it. Much tougher problem, but one step at a time, it's okay. Now, I want to step over here for a second while you're still digesting that. Just like geometry, remember when you took geometry and they gave you a proof to do, and there were kids who did it in 3 or 4 steps, and then maybe you did it in 20 steps? It doesn't matter. As long as you get it, it doesn't matter. So we said that from the beginning, another path we could have taken was this one. Now, if you chose this path, what do you think you might do with your tangent squared? Sine squared over cosine squared. Now, if I do the same thing I did over here, multiply by cosine squared to get rid of that fraction, I would have sine squared over cosine squared sine. Now, do you see how we're back to where we matched up with one of our other steps? From then on, it would be exactly the same. It's just a different way of getting there. Now, let's try another one. Pick another even there on page 460. What do you think? Page 460, pick another even one. Huh? 28. Delaney, were you going to give me a problem, or did you have a question?
I was just going to say 24.
Okay, we'll do 24 next. So 28 is cotan minus 1, cotan plus 1, equal 1 minus tan. Okay, now, I want to point out that you get no points for doing nothing. Okay, you have to do something. So when you look at this problem and you know you are only allowed to work on one side, these sides look about the same level of difficulty. It's not like one of them's a lot bigger than the other one. They're about the same. Pick the side you know you can do something on. So does anything occur to anybody on either side of this identity? Cotangent? Now, my gut feeling is always change into sines and cosines, because I know that will always be okay. I know I can always start that way. But this time I'm thinking a little smarter. If I work over here, this is what I want to end up with, right? So I don't want to end up with sines and cosines. I want to end up with tangents. Can I change cotangents into tangents? Yes. What is cotangent? 1 over tangent. So let's just go ahead and change this into 1 over tangent. Now, if I changed into cosine over sine, would I eventually get the right answer? Yes. But if I change into sines and cosines, then at some point I'm going to have to change it back into tangents. Do you understand what I'm saying? So since I have the ability to go straight from cotans to tans, that's what I'm going to do. Now I have this huge, ugly fraction. Think about what we just did. I want to get rid of this. I'm going to multiply every single term by tangent. Everything by tangent. The purpose of that is to make these cancel. Does everybody see that? So what do I have up here? 1 minus tangent. And what do I have down here? Oh my goodness gracious. That's it. You did it. 2 steps. Sometimes the ones that look very scary are the easiest ones. Let's look at 24. There is no right, there isn't just one right first step. So as I write down the problem, as you look at number 24, you be thinking about, okay, what can I do to get this ball rolling? That's a Greek letter beta. If it bothers you, change it to a B or an X or a P or a Q, who cares? Don't let the letter bother you. So looking at the problem, you got to think of something. Maria, you don't think you should write any of this down? It's up to you. I don't care. It's just, these are kind of hard. What do you think? Anybody have an idea? change everything into sines and cosines? That probably wouldn't hurt. I might do an intermediate step. What's 1 over tangent? So I might think of that as cotangent plus tangent. Now I'm going to change into sines and cosines. So what's cotangent again? We've already talked about it.
Cosine over
Cosine over sine. And what's tangent? Sine over cosine. Okay, good. So we have changed into sines and cosines. These are two fractions that need to be added together. How do we add fractions? Get a common denominator. What's our common denominator going to be? Sine, cosine. So this one needs to be multiplied by cosine. And this one needs to be multiplied by sine. Do not be confused. This is 3rd grade arithmetic with trigonometry instead of, you know, N's and Q's or something. You're getting a common denominator. So my common denominator is cosine sine. What's this part of the numerator? Cosine squared. What's this part of the numerator? Oh my gosh. I don't know if I'm having a hot flash or if I'm just super excited, but my heart's just pumping like crazy. What's in my numerator? 1. So my numerator is 1. Now we think kind of backwards, okay? This is the same as 1 over cosine times 1 over sine. Now, I don't want anybody to be confused by that. If you multiply these two together, is that what you get? But for purposes of this problem, I need to separate them so that I can look at 1 over cosine and think what? What's 1 over cosine? Secant. And what's 1 over sine? Cosecant. And that's what I wanted to end up with. Okay? All right, let's pick one more, and then I'm going to let you get started. I'll do one more for you. So pick an even one on page 460. One that looks scary. 34. Oh, that's a great problem. All right, let's look at 34. And by the way, do you think you're going to be able to do every single one of the problems you tried tonight?
Yes.
Probably not. I mean, that's awesome. I hope you can. But if you can, we're not panicked about it. We're going to start every one. We're going to get it as far as we can, right? That's my expectation. You get as far as you can with every one. All right, so let's look at this one. Now, this is really one where people are going to want to cross-multiply, but you can't. That's not an option. There aren't very many things that you're going to get 0 credit for, but cross-multiplying is one of them. If you cross-multiply, you get no points. Does it really matter which side I start on? No. So I guess I'll just start over here, or, you know, on the left side again. Doesn't matter. I have this, I want this. Now this is a little bit tricky because there is no way to change these into those because none of them are squared. Remember, you can change sine squared into 1 minus cosine squared, but you can't change a plain sine. If they're not squared, you can't change them. So there really is no identity, you know, by the ones I memorized to get me from here to here. So this is what I'm going to do. I'm going to look at this and say, okay, that's what I want to end up with. There is a sign in the numerator of what I want to end up with. There is not a sign in the numerator here. So I am going to put a sign into the numerator. I am going to multiply the top and the bottom of this side by sign. Now, is that legal? You may be saying, why would you do that, Mrs. Ford? But is it legal?
Yeah.
It absolutely is okay. Now, what does that put into my denominator at this point? Now I have a sign squared in my denominator. Why is that kind of good news if this is what I'm trying to end up with? What is sine squared? 1 minus cosine squared? So I'm going to take my denominator now and change it into 1 minus cosine squared. And again, it's because this is what I'm trying to end up with. There's cosines down there. So it makes sense to rewrite my sine squared as 1 minus cosine squared. Now, think about what we did at the very beginning of the period. What did we do with 1 minus cosine squared at the very beginning of the period? We factored it. Can you see where I'm going with this? What's going to happen when I factor my denominator?
It's going to simplify.
After you factor, you can always, cancel if it's not, if things cancel. You're allowed to cancel after you factor. So these are going to go away, and I'm going to be left with sine over 1 plus cosine, which is what I wanted. Now, my job, I can't teach you how to prove. You gotta have a brain. You gotta be able to have a brain to do that. I can fill your toolkit though. So what I just did was give you another idea, another option. If you don't have what you need, you can put it into your problem. Now you can't just put it in the numerator and you can't just put it in the denominator, but if you put it in both, it's legal. Katie?
Will you always be able to prove these, or does we want like?
Okay, that's a great question. Yes, my commitment to you is they'll all be provable. Now, in the real world, or maybe in honors pre-cal, they're not all provable. But it gets a little confusing, especially for first-timers, when things don't come out right. So your job is to prove it. I will give you provable ones. Okay? All right, so I want you right now to get started. This is not time to be doing anything else. This is time to get started. So here is what I want you to get started on. I want you to do 1, 3, and 11 to 25 odd. 1, 3, and 11 to 25 odd. Now, 1 and 3 are algebra. Why are these out? Who cares? Who cares? The inability to see a problem from a new perspective. By employing a different mental set. I need to employ a different mental set. Put those away right now. John, would you turn that off, please?
And I was just messing around with it during the day.
Everybody